Welcome students. In this video, we'll learn about laws of friction, angle of friction, angle of repose, and acceleration of a body on rough surface. There are some laws of friction. First one, the direction of limiting friction is always opposite to the direction in which motion takes place or tends to take place, and it is tangentially along the surface of contact of two bodies. Suppose this is a rough surface and a body is placed over the surface. Now, a force is applied on the body to move the body towards right. Therefore, the friction acts tangentially in between these two surfaces and it is directed opposite to the motion of the body. Next one, magnitude of friction is directly proportional to the normal reaction between the surfaces. Now, if the body is placed on the surface and the mass of the body is m, then the weight acting towards downward, that is mg, and the reaction force applied on the body by the rough surface is upward, vertically upward, that is r. If we consider the body as a system, then here r is equal to mg. And frictional force F is directly proportional to R. Therefore, friction is equal to mu into R. Here mu is known as coefficient of friction. For static friction, Fs is equal to mu s into R. This is equal to mu s into mg. And for kinetic friction, Fk, this is equal to mu k into R is equal to mu k to mg. Here mu s and mu k are the coefficient of static friction and kinetic friction respectively. The third one is friction is independent of area of the surface of contact of two bodies and it depends on the nature of the surface. Suppose a body is placed here, a block is placed here, a force is applied on the block and this is mg. This is the reaction force upward, this is R. If the block remain at rest, here the frictional force acting in between these two surfaces, that is F. Now, another identical block is placed over it, like this. And here also, same force, that means now here 2F is the amount of force applied. The reaction, that is 2R, weight is 2 mg, and frictional force is 2F if the block remain at rest. Similarly, two blocks, identical blocks, are placed like this, side by side, and two blocks are connected. Now here 2F is the amount of force, 2 mg is the weight, 2R is the reaction, and 2F is the frictional force. In these two cases, as the block remain at rest, therefore frictional force remain same, but the area of contact between the block and the surface are different. Therefore, frictional force does not depend on area of contact, but it depends on the roughness. It depends on the nature of the surface. Angle of friction. The angle between the normal reaction and the resultant of limiting friction and normal reaction is called angle of friction. A body is placed on a surface. Here, force is applied on the body, that is F. The frictional force acting in between the surface in this direction, frictional force is acting, that is small f. If m is the mass of the body, then mg is the weight, and R is the normal reaction. Normal reaction on body by the surface. There is a resultant vector in between R and F. We can draw a parallelogram here. The diagonal gives the resultant vector. Suppose this is R prime. Okay. R prime is the resultant of normal reaction and frictional force. The angle between normal reaction and the resultant, that means R prime, is known as angle of friction. Here theta is the angle of friction. Now if we consider the triangle, this triangle, this side is also F, so tan theta is perpendicular by base. From laws of friction, We know that F is equal to mu into R, where mu is the coefficient of friction. Therefore, F by R is equal to mu. Therefore, we can write tan theta is equal to F by R is equal to mu. So we can say that the coefficient of friction is numerically equal to the tangent of the angle of friction. Angle of repose. A body is placed on an inclined plane and the angle of inclination is increased gradually. Therefore, for a specific angle of inclination, the body having a tendency to tends to slide over the surface. That specific angle of inclination is known as angle of repose. Therefore, we can say that the minimum angle made by the inclined plane with the horizontal surface such that the body lying on that plane is just at the verge of sliding down along that plane is known as angle of repose. Here, phi is the angle of repose. That means the specific angle of inclination. Now, m is the mass of the body. Therefore, weight, this is mg. And if we resolute that force, that means weight, into two components. One is along the inclined plane and another is perpendicular to the inclined plane. Then this is mg sin phi and this component is mg cos phi. If we draw an inclined plane and this angle is phi, suppose here we placed a point mass mg, this is perpendicular to the surface. Therefore, this angle, this is 90 degree minus phi. Now, if we resolute this mg in two components, one is along the inclined plane, another is perpendicular to the inclined plane, then this angle is phi. This angle is phi. Therefore, the component which is near to that mg, that means near to the force, this is mg cos phi, and which is far away, this is mg sin phi. Now, the normal reaction is that is R, and frictional force acting here along the inclined plane in opposite direction of mg sin phi, this is F. Now, as the body tends to move downward, therefore, mg sin phi is equal to F and mg cos phi is equal to normal reaction. Therefore, mg sin phi by mg cos phi is equal to F by R. Or we can write that tan phi is equal to F by R. This is equation 1. From laws of friction, we can say that F is equal to mu into R. where mu is the coefficient of friction. Therefore, we can say that tan phi is equal to F by R is equal to mu. From angle of friction, if theta is the angle of friction, then tan theta is also mu. Therefore, we can say that theta is equal to phi. That means angle of friction is equal to angle of repose. Acceleration of a body on rough horizontal surface. A body is placed on a rough surface and a force is applied on the body. Due to that force, the body is moving in that direction with an acceleration a. As the body is moved on the rough surface, therefore a friction acting in between these two surfaces, and the frictional force, that is Fk. K stands for kinetic friction. As the body is in motion, therefore the body is moved due to unbalanced force. Therefore, the net force acting on the body is F minus Fk. This is equal to ma. Here m is the mass of the body. Mg is the weight of the body and R is the reaction force. Therefore, R is equal to mg. As the body is not moving upward, therefore, along the vertical direction, the resultant force is 0. For that reason, R is equal to mg. If mu k is the coefficient of kinetic friction, then Fk is equal to mu k into R. Therefore, F minus mu k into R is equal to ma, or F minus mu k into mg is equal to ma. Therefore, acceleration is equal to F by m minus mu k into g. Acceleration of a body on rough inclined plane. A body of mass m is placed on an inclined plane of inclination theta. This is greater than angle of repose. Therefore, the body is moving downward with an acceleration a along the inclined plane. The weight of the body, that is mg, acting downward, and it is vertical to the ground. Now, if we resolute that weight, that is along the inclined plane and perpendicular to the inclined plane, then along inclination, the component of weight is mg sin theta, and the perpendicular to the inclined plane, that is mg cos theta. This mg sin theta, this component, move the body towards downward along this plane. As the body is moving on a rough surface, therefore there is a frictional force acting in between these surfaces. The frictional force is acting here, that is F. If R is the normal reaction of the body, then frictional force F is equal to mu K into R. Here mu K is the coefficient of kinetic friction. As the body is moved due to unbalanced force, therefore the net force acting on the body is mg sin theta minus friction. This is equal to ma. So mg sin theta minus mu k into r is equal to ma. As the body is moving along the inclined plane, therefore the vertical component of force with respect to inclined plane acting on the body are balanced. Therefore, R is equal to mg cos theta. So, ma is equal to mg sin theta minus mu k into mg cos theta. Therefore, acceleration of the body is g sin theta minus mu k cos theta.